So welcome back everyone. So let us continue with our second topic, which is lecture 2. We'll be continuing with coordination compounds, a very important topic. Again and again I am telling you. So they can ask you many questions. Every subtopic is very important in coordination compounds, especially from inorganic chemistry point of view. So we have ended our last class with a question which is ethylene diamine tetraacetate EDTA ion is what? So EDTA has two diamines and you have tetraacetate in it. So there are two nitrogen atoms which are donors and four oxygen atoms which are donor. So you have hexadentate ligand with four oxygen atoms and two nitrogen donor atoms. So B is right answer. Next, let us see. A chelating agent has two or more than two donor atoms to bind to a single metal ion. Which of the following is not a chelating agent? So you need to understand first what is chelation. So we'll come back to this point in the next slide. But first you need to understand chelating agent is something which is making your compound more stable. So this is the point you need to understand. So it is making your compound more stable. How does it make it? By has two or more than two donor atoms to bind to a single metal atom. So it has, this is your metal atom, suppose if this is your metal atom, you have the chelating atom. We suppose if I have a compound like this, I have donor X, Y. So I have this as donor, this as donor. So these two, more than two donors also you can have it. So these two bind together a single metal atom. So which of the following is not chelating? Which of the following does not have more than two donors is asking. So oxalato has COO minus bonded with COO minus. So you have two oxygens here which are ligands. So this is not the answer. Next, we have discussed about glycinato in our previous class. If you don't understand what are these oxalato, glycinato, ethane 1,2-diamine, how these structures will be, how they donate and make a bond, how they will be acting as ligands. These all things has been discussed in our previous class. So please go through them and come back to this topic again. So again, this also has two donor atoms. We doesn't need it because this is nothing but glycine and amino acid from which you are deriving. Two ligands will be there, which is amine and oxalato is also, carboxylato is also present, COO minus. So you have ethane 1,2-diamine, this is also not. So your answer is A. Thiosulfato. Next is a metal atom. What is meant by chelate effect? So I told you, the presence of two or more than two donating atoms will be there. They will be acting as ligands here. So what does this do actually? If you think in a thermodynamic point of view, chelation is something which maximizes the stability of the compound. How does it maximize the stability of the compound? Suppose if you have a metal atom, you have many donating atoms, mostly are monodentate. Okay. Now suppose if you have a compound where it has more than two donating atoms. Suppose if you have Y, Z, all are your donating atoms only. All will be acting as your donating atoms, suppose. This is an example. So this can donate, this can donate, this can, or you can take generally a two structure. You can take a structure like this. So now if you see 1, 2, 3, 4, 5, 6 atoms are there in this, out of which 2 are your donating. So what does it do is, there are 2 donating atoms. Out of these 2 donating atoms, your structure is expanded in such a way, it will form a ring structure which maximizes the stability. How does it maximizes the stability? You need to understand it is maximizing its stability means it is increasing the thermodynamic, it is increasing the entropy from a thermodynamic point of view. How? The strain inside the material is decreasing. You are decreasing the strain inside the material and this effect is called as chelation. So forming a ring structure and decreasing the strain inside the material, increasing the stability, it can form more than this. See here, you got a 6-membered ring here. There is 7-membered ring, there is 7th member is this one. Or you can have a 6-membered chain also. You can have a 5-membered chain also. But forming a chain structure, it is increasing the stability of the compound by decreasing the strain overall. This is called as chelation effect or chelate effect. Next, so you understood this. So a chelating compound, identify the correct statements, the behavior of ethane 1,2-diamine. So these ligands, even if they have more than 1 or 2, they need not be charged every time. So example, you take cyanide. Cyanide has negative charge. You have any other compounds also. Suppose if you have nitrate, everything like chloride, everything has negative charge. They can be positive ligands also. But now you need to understand, they need not be every time a charged species need not be a ligand every time. It can be a neutral species also. Example, this one. So your ethane 1,2-diamine has, it's a neutral ligand, it's a bidentate ligand. You have 2 amine groups in it which are donating to form ring structure, and it is a chelating ligand. So overall it is spreading a chain like this. So you have CH2, CH2, NH2, NH2. You have metal atom. These two are donating. You get a 5-membered ring. So 5-membered ring, 6-membered ring increases the stability of the compound. So overall it is ABC. It is not a unidentate ligand. Next, which of the following species is not expected to be a ligand? So you see this ethylene diamine, just now we have discussed. This is a ligand. CO, carbon monoxide, is also a ligand. Generally it has a dative bond in this. Next, NO is also a ligand. So one which is not a ligand is this one, NH4 plus. This is the one which does not have a ligand, does not behave as a ligand. Next, the stabilization of the coordination compounds due to chelation is called as chelate effect. So this is what we have discussed previously. The stabilization of coordination compound due to the chelation is called as chelate effect. So which one of the following is most stable among the species? So you need to understand there need to be at least more than 2 donating ligands, out of which it will form a ring structure. So these are monodentate ligands. This is a monodentate ligand. C2O4 is a bidentate. This is again a monodentate. So your answer is C. Right? So you have Fe, C2O4, this COO minus, these two are acting like this, and there are 3 structures like this. You have this as AB, AB, AB. You have 3 structures like this. Which of the following is an ambidentate ligand? I told you already, the ambidentate ligands are the one which can donate, like they can turn their position. Suppose if you have AB, first time if A is bonding, second time B also can bond. These are called ambidentate ligands. Example, which of the following is ambidentate? So NH3, there is only one ligand which is N, which is the N has a lone pair which is attacking your metal atom, central metal atom. Oxygen is the one which carries. Fluorine has lone pair again. SCN, sulfur can attack, or nitrogen also can donate. So both of these, if you consider SCN and NCS. So if S is the one which is donating, you will get thiocyanato. If N is the one, you will get isothiocyanato. So here SCN is the answer. Next, which of the following is a flexidentate ligand? Flexidentate ligand is the one which can exhibit different densities depending on the type of structure it requires. So there are more number of donating groups in this structure, Na2, EDTA. Your H2O is a monodentate, Cr is a central metal atom, you don't have this. NO2 minus is again a monodentate, so you have EDTA, which is flexidentate. Next, which of the following is unsymmetrical bidentate ligand? So unsymmetrical, if you take this oxalato, if you take, you have CO minus, this is symmetrical. You have CH2, NH2, this is also symmetrical. SO4, this is it's not a bidentate ligand only, it is a monodentate ligand. This is a bidentate ligand which is unsymmetrical. You have CH2 bonded to NH2 and you have COO minus. So this is your bidentate ligand which is unsymmetrical. Next, which of the following is a chelate complex ion? So when you talk about chelate complex ion, you need to think again about ring structures. So these are monodentate, these are monodentate, these are monodentate. Only A is chelating, which has En in it, ethylene diamine. So denticity of a DMG ligand is, DMG ligand we have already discussed in the previous class. Once again, if you have any doubts, please revisit your previous slide. So it is nothing but dimethyl glyoxime. So dimethyl glyoxime, what is the denticity of it? It is nothing but 2. So you have 2 donors in it, in DMG. Next, now till now what we have seen is denticity, the properties, everything we are seeing now. So now we need to understand there are certain rules to write names. Just like in organic chemistry, how you write the names of organic compound, in the same way these coordination compounds also has certain rules which you need to follow while writing the names of it. So how do you identify what is a different kind of structure? Suppose if it has 2 different kind of structure, molecular formula is same. How do you identify? With the name. This structure is different, this structure is different. They both will be identified with the names. So there are certain rules which you need to follow. So the following rules are applied while writing the formulas. Who gave it? It's a mononuclear coordination entities. So the central atom is the one which you'll write it first. Next, central atom is listed first. Then the ligands are then listed in alphabetical order. You need to understand whatever ligands are there. You identify the ligands which are present. Suppose you have chlorine. Suppose if you have NO2 minus, if you have NO3 minus, you identify all these ligands and you will be writing them in an alphabetical order. The placement of ligand list does not depend on its charge. So here you won't say one which has positive charge, one which has negative charge. Depending on it, we'll be giving the name. No, you'll be giving the order of alphabetical order. The ligands will be written in the alphabetical order. The polydentate ligands are also listed alphabetically. Even suppose if you have En, if we have ETDA, this En is what? Diethyl. So you'll start with ethyl, E. You have chlorine. So you'll be writing it as chlorido. So chlorido it comes with C. You have ethyl, E. E will come afterwards. So you'll be writing in alphabetical order. So the first letter of the abbreviation is used to determine the position of the ligand in alphabetical order. So you will be using first letter. First letter does not mean numbers. Those all will be seeing it again. So what does this number means also we'll be seeing. The next one, the formula for the entire coordination entity, whether charged or not charged, is enclosed in a square bracket. So we have seen in the starting itself, this part, this is called as coordination entity. This coordination entity, whether it is charged or uncharged, you will be writing in a square bracket. Suppose you will be writing it as MA3B3. This is an example. So you will be writing this as square brackets. When ligands are polyatomic, their formulas are enclosed in parentheses, like ethylene diamine. So you will be writing them as, in the square brackets, in the parenthesis, you will be writing it as ethylene diamine. So you will be writing it like this. So when the ligands are polyatomic, you will be writing their formulas in enclosed parenthesis. The ligands abbreviations are also enclosed in parenthesis. That is what we have written. There should be no space between ligands and metal within coordination sphere. So there won't be any space between the ligands and the metal within the coordination spheres. You won't be writing it as, you'll write metal atom here, you'll give some gap and then you'll be writing the ligands again. No, you'll be writing it as Ma3B3 in the same way. You won't be writing it as M separately, Cl separately, Al separately. It's not like that. Right? Next. So rules for writing the formula continuation. The formula of the entire coordination entity, whether charged or not, is enclosed. The charged coordination entity is written without the counter ion. The charge is indicated outside the square brackets or as right superscript with a number before the sign. So what does this mean? Suppose if you don't want to write the counter ion, what is a counter ion? Suppose I gave you potassium ferrocyanate. Ferrocyanate is a complex part, potassium is the ionized form. So this potassium, whether you want to write it or not, you can write a charge on the coordination entity. So how do you write it? So coordination entity here, COCN6 3 minus. So you have a positive positive counter ion. Here you see, because that separates, then only you will be getting a negative sign here. CrH2O6 3+. So these are superscripts. These superscripts include, they say like the counter ion is a cation or anion. Here you can understand the counter ion is a cation. Here you should understand the counter ion is an anion. The charge of cations here you need to understand is balanced by the charge of anions. So overall charge is balanced. Overall the complex which exists, the overall charge is balanced. Now the following rules are used when you want to name the coordination compound. So how do you want to name it? You need to identify whether they are anions or cations. Which is anionic part, which is cationic part. The compounds which are present in cationic part and anionic part, how do you define or how do you write their names? We'll be understanding them. So always the cation name is written first in both positively and negatively charged species. Whether you take coordination entity has positive charge or negative charge like this. Suppose this is positive charge, this is an anionic part, this is cationic part. In this you need to understand the counter ion which is positive, that is your cation, this is your anion. And here this is your cation, the counter ion is your anion. Whether you have this or that, the cation is the first which is named first in both positively and negatively charged coordination compounds. This you need to remember for sure. This is very important. The cation is named first in both positively or negatively charged coordination compounds. Next, the ligands are named in alphabetical order before the name of central metal atom. So before you write your central metal atom name, suppose you write your central metal atom name, before that itself you will be writing all the ligand names. Just like in organic chemistry, you will be writing all the substituent names before the main functional group. In the same way, you will be writing ligands in the alphabetical order before the name of the central atom. This procedure reversed while writing the formula. When you write your formula, you will put central atom first and then you will put your ligands next to it. The name of the anionic ligands end with O. This is very important again. The name of the anionic compounds end with O. Suppose if I say chlorine, you will be writing it as chlorido. Anionic ligands. So those of neutral cation ligands are the same name you will be writing it. But you need to understand, except for the names of aqua, H2O, amine, AMMINE, amine, NH3, carbonyl, CO, nitrosulfur, NO. So except this, suppose if I have NO2 minus, I will be writing it as nitrito. If I take NO3 minus, nitrato. So you will be taking name of O in the anionic part. But those with a neutral and cationic ligands are the same except for H2O, aqua, you will have NH3, amine, carbonyl, CO, nitrosyl is for NO. While writing the formulas, these you need to understand and they will be kept in brackets. Now, prefixes like mono, di, bi, tris, tetrakis, they will be using if there is already names like di, bi in your compound itself. Like you see diethyl diamine. So now you have ethylene diamine, you have two amines in it. So when you write the compound, if En is only one, that is not an issue. But there are two Ens as ligands in your compound, you will be writing it as bis, not di. Right? That is what he is saying. The prefixes like mono, di, tri are used to indicate the number of individual ligands. For the next one, when the names of the ligand include numerical prefix, then bis, tetrakis, tri are the ligands. They refer being placed in parenthesis. For example, NiCl2 PPH3 twice is the name of chlorido. So how do you write this? So you have chlorine. So identify the atoms which are present in this, or I mean ligands which are present in this. First is chlorine. Next is PPH3. You will be writing it as triphenyl phosphine. Now, which comes first? This is phosphine, triphenyl. So P comes next. So first chlorine comes. But you need to understand for the anionic part, you will be writing ending with an O. This is chloride. Chloride you will be writing. Chlorido. But how many chlorines are there? Two. So you will be writing dichlorido, triphenyl phosphine. This you need to put in a bracket. See, like this parenthesis. Then nickel. Nickel, 2. Because the overall charge left here is, there is no charge here, you have minus 2, you take x minus 2 is 0, so you have overall charge as 2, right? So you will be taking it as nickel 2. Next, rules for naming continuation. The oxidation state of metal in cation, anion or neutral coordination entity is indicated by numerical, Roman numerical in parenthesis. So that is what we have written in previous case. So nickel 2. 2 is the oxidation state. Oxidation state also you will be putting in Roman number but in parenthesis. You won't be writing it as 2 or 1. You will be writing in Roman numbers. So if the complex ion is a cation, the metal is named as it is. If it is a cation, the metal is named as it is. But for example, cobalt, you will be, CO is a cation, you will be calling it as cobalt. Platinum, you will be calling it as platinum, PT. But if the complex ion is an anion, then the name of the metal atom ends with 8. For example, you have iron. Ferrous, you will be writing it as ferrate. Platinum, if it comes in your anionic part, it is called as platinate, nickelate, chromate, like this. The neutral compound molecules is named similar to that of complex cation. So there won't be any change in the name of the compound as you write as in cations. So let us do some questions which are very important and came as PYQs previously. The IUPAC name of the complex Ag H2O twice Ag Cn2 minus. So here you need to understand this is negative, this is positive. So there is no charge here. Overall charge on Ag is plus. So how do you get it? Ag plus, Ag plus. So it is x minus 2 is equal to minus 1. So you will get Ag plus again. So this is your cationic part. This is your anionic part. Always you will start naming with cationic part first. So cationic part first, if you write it, what will you get? You will be getting di-aqua, di-aqua silver 1, and you have di-cyanido. In anionic part you have negative charge. No? This is cyanide, Cn minus. So this is cyanido argentate 1. So you have C as your answer. Di-silver 1, di-cyanido argentate 1. Next. So write the formulas for the following coordination compounds. So you need to identify what are there first, we'll understand. What are the ligands which are present, we'll understand. So you have tetraamine. So you have NH3, we'll change the color. So you have NH3 4 times. Next you have aqua. They didn't mention any number, right? So it is only H2O, aqua. You have cobalt, and you also have chlorido. So there is one more chlorine here. So you will be putting them in parenthesis, I mean square brackets. Then you are left with chlorine. But the overall charge is given as 3. So it is Cl2. Then only you will be getting 3. See here, there is no charge, there is no charge, there is minus 1. So x minus 1 should be 3. Then it should be plus 2. So there are 2 chlorine atoms extra. But this number won't be shown here. You will be writing it as only chloride. So ion which is present completely outside, you will be writing it the common name itself, but you will be writing cationic name part first, anionic part next. Next, potassium tetrahydroxido zincate. So you need to understand hydroxido is nothing but OH. So you have OH4, potassium tetrahydroxido zincate. So you have zinc, you have potassium. You need to have a charge here plus 2. So when you have plus 2, it is already x minus 4. There should be plus 2 means there should be a minus sign here. So you need 2 potassiums here. Okay. Next, potassium trioxylato aluminate. So you have aluminium with C. You can write oxylator, no? So you can write OX tri. This is your complex compound. Then you have potassium. So already you have x minus 3, x minus 6. There should be a positive charge plus 3. So you should have K3 here. So overall when it is minus 3 only, Al will become 3, oxidation state. This is nothing but your oxidation state. So aluminium will have an oxidation state. As it is present in anionic part, you will be writing it as aluminate. Right? In anionic part, you will be adding 8 to it. So here zincate. Cobalt is in cationic part. Zincate is in anionic part. So this is aluminate. Next, dichlorido bis ethane 1,2-diamine cobalt ion. So you write cobalt first, then you have En. En, you have bis here. So bis means there are 2 ENs. Dichlorido, so you have 2 Cls. Overall, your hexadentate has been finished. But you have a charge of 3 here. So you are left with one more chlorine, because this is x minus 2, you need to have this as 3. So you need to have a positive charge here. If this is a positive charge, this is a negative charge. So overall it is cobalt dichlorido. So here nowhere chlorine is mentioned, it is given as ion. So that is why you won't be writing this chlorine here. So it is just a positive charge which is present outside. Next, tetracarbonyl nickel 0. There is no charge actually, but nickel has carbonyl and you have 4. So overall your charge is 0. So this is how you write, you convert these IUPAC names into compounds. This is how you write the compounds. So please note it down. Let us continue. So write the IUPAC name of the following coordination compounds. See, a best practice for this will be, if you try it on your own, I'll explain you 1 or 2 answers. Please write the remaining in the comment sections. So that will be a good practice for you. So first one, platinum, amine, you have amine here, diamine, chlorine. So we'll identify what are the amines. You have chlorido, next you have nitrito, then you have, so nitrito N, this is nitrito N because N is attached directly, and you have diamine. Next is cobalt, platinum. So you have platinum here. So you don't have any charge here. So you will write a neutral charged central atom has this itself. But what do you have here? Overall, there is 2 charge here. You have, this becomes 0. This becomes 0 when your chlorine -1, -1. You have 2 here. You will be writing this in parenthesis. But how do you write the name? This is not the actual name. You should write in alphabetical order. So first diamine will come, next chlorido will come, only 1 chlorine is there, next nitrito N, next platinum. So if you write in an order, you will be having the name as diamine, you have 2 M's here. So you have diamine, chlorido, nitrito N, you have platinum 2. Okay. Next, you have potassium. So write potassium at the starting. Potassium, chromium, chromate, because this is an anionic part, right? So you have chromate. You write your oxidation state in the brackets. What do you have here? Tris. Okay, you can write this as carboxylato. Okay, you'll be writing it as tris carboxylato. Chromate. Next, chromate charge is how much? Here it is +6, x minus 6 equal to +3. So it is x minus 6 equal to 3. So you have 3 here. Next, you have cobalt dichloride, diethylamine, then you have chlorine. So first you will be writing dichlorido, diethylamine, sorry, ethylene diamine, next what do you have? Next you have cobalt. So what is the charge? Then you have chloride. So what is the charge? There is a +2 here, x minus 2 is equal to +1, so it is 3. So please do the remaining two questions as practice and answer them in the chart section. Very easy. You have cobalt, you have pentamine, you have carboxylato. Then okay, this is oxalato, trioxalato. Then you have carbonato you will be writing. Then you will be writing chloride along with your cobalt charge. You can write oxalato or carboxylato. Please do them and write them in the chat box. Oh, sorry, I didn't see the name of this. You have ethane 1,2-diamine. You have bis for this. Okay. Next, the name of the complex ion FeCN6 3-. So you have Cn, Fe, already you have ferrate because this is an anionic part. Fe, you have 3 in the last part. So identify everything has 3, everything has ferrate. So this is chlorine. Okay, this is not there. Iron is given. Next, hexacyanide. Hexacyanide. So D is your answer. Next, the correct IUPAC name for chromium F2 En twice Cl. So you have chloride at last. So this is not there. You have chromium charge as -2 and +1. So you have 3 overall. So 3 chloride, 3 chloride. You have this in the cationic part. So you'll be writing chromium, chromium, chromium. So this is also correct. Next is ethylene diamine. So this is ethylene diamine. You have ethylene diamine. But how many are there? Bis ethylene diamine. Before this it's a fluoride. But E comes first or F comes first? Right? There is one more atom which is chlorine. So that is not there. So what do you have here? You have difluorido bis ethylene diamine. Difluoroethylene diamine. So you have C as your right answer. This is fluorido. Then you have ethylene diamine. Next, according to the IUPAC name, nomenclature, sodium nitroprusside is a name for. This is a very important compound which generally has been repeated many times in JEE Main point of view also. So sodium is there, nitroprusside is there. So what is this sodium nitroprusside? You have sodium, you have nitrosyl group in it. So how do you get it? You have 5 nitrosyl groups in it with cyanide. So you have sodium, pentacyano, nitrosyl ferrate. You have ferrate which is what? So you have 5 cyanide, overall 6. How many sodium atoms are there? 3. So it is charged with 3. This is your answer. So it is sodium pentacyano, nitrosyl ferrate. Oh, sorry. Pentacyano, nitrosyl ferrate. Ferrate is with 2 because ONO is there. Nitrosyl, pentacyano, you have overall 6 and you have nitrogen, 4 sodium atoms will be there, NF4. So you have answer as D. Sorry for the mistake. Now, which of the following determines the position of the ligand in a mononuclear coordination entity formula? So you need to understand which of the following determines the position of the ligand mononuclear coordination entity. So what does the position of the ligand in the mononuclear compound will tell you? It is not charge, it is not atomicity, it is not density, it is first letter in the alphabetical order. So you will be writing it alphabetical order. So IUPAC name of platinum NH3. So you have amine here, you need to name it, amine is there. So you have triamine. Next you have bromide, so you will write it as bromo. Next you will be writing with nitro. So this is nothing but nitro group. So how many nitros are there? There is one. And you have chlorido. So you will be writing it as chloro, because this has been in the part of the cationic part. You will be writing everything as chloro, bromo, like that. So you have amine which comes first, triamine, correct. Next you have bromo. Next you have chloro, bromo, chloro, nitro, platinum 4, chloride. So those are in your alphabetical order. Next, the complex potassium, nickel, cyanide. Cyanide is tetracyano. You have in the nickel, nickel is in anionic part. So anionic part means you will be writing it as nickelate. Nickelate sign will be 2, because oxidation state is what? X minus 4 equal to minus 2. So X is plus 2. So oxidation state is 2. So C is their answer. Potassium tetracyano nickelate. Next, these questions are the subjective type of questions which used to come previously in your JEE Advanced, and also they used to come for NEET exams also. So give the IUPAC name of ionization isomer of NiNH3 thrice NO3Cl. So this is very logically, if you think, before understanding what is ionization isomer also, there should be a type of isomer. This is a type of isomer where the position of the ions can be replaced or can be changed. So the ionization isomer of this is NH3 thrice Cl NO3. Okay. If you ask me the name of this compound, if you ask me, this is nothing but you have triamine. This is nitrato with N. N is bonded first. So it is nitrato. Then comes nickel. This is cationic part. So you will call it as nickel. In the bracket, you will be writing chloride. So what are the signs? You have only -1, you will be writing this here. But now, it is not in the cationic part. You are writing ionization isomer IUPAC. So it is again triamine. Next comes chlorido. Next comes nickel. You will be writing it as nitrate. What is the sign of this again? 2. Okay. Oh, this came in cationic part, right? This came in cationic part, so you will be writing it as chloro. So this is chloro, because this is in cationic part. If it is anionic part, you will be writing it as chlorido. What is the ionic IUPAC name of the complex NiNH36Cl2? So you need to think of this. You have hexaamine. You have nickel. What is the charge? Charge is 2. This is cationic part, that is why I am writing nickel. Then you have, right, chloride. Okay. This is the way in which they used to ask in previous. These questions are very good actually, very interesting questions. Write down the formula of tetraamine aqua chlorido cobalt chloride. So you identify this, you have cobalt, then you write the compounds, tetraamine, you have NH3 4 times, aqua you have H2O, then you have chlorine, then you have chlorine on the outside also. So how do you define this? So the charge is X minus 1. You need to have 3. You need to have 3 means you have So x minus 1 should be equal to 3, oxidation state. So x equal to 4. Oh, sorry. This is equal to 3. X is equal to 3 directly. 3 minus 1, you need to have 2. So you need to have plus 2 here, means you need to have 2 chlorines here. So overall, you'll be getting charge like this. So if there is plus 2 here, then only you'll be having cobalt oxidation state as 3. Okay. Write the IUPAC name of the following compound. So this is what? Hexa, amine, cobalt. You have cationic part only, no? So this is 3. Cobalt 3. That's all. This is ion. There is no other anionic part. Write the IUPAC name of the following coordination compound. Nickel Cl4 2 minus. So please try it on your own. So these writing IUPAC names is very, very important. There will be a definite JEE Main question. You can expect for sure. There will be definite JEE Main question to confuse you, or they'll give you the same type of names also. You need to identify, keep clear in your mind. Anionic part you will be adding O to it. For the metal you will be adding 8 to it. And for cationic part you will be writing names as it is. Chloro, bromo, like this you will be writing. And metal names will be chromium, ferrous, like this. So IUPAC name, this is anionic part. So you have nickelate and the charge is 2. You have tetrachlorido. There is no cationic part, so you won't be writing at the first. So you have tetrachlorido nickelate 2. Okay, done everyone. So let us continue. IUPAC name of the complex COCl2En plus. So this is cationic part. You will be writing it as cobalt. Cobalt, the overall charge is 3. Oxidation state is 3. You don't have any anionic part. So you will be writing in alphabetical order. It is diamine, dichloro, because this is cationic part. So you will be writing it as diamine, dichloro. Then you will be getting cobalt. Oh, this is not amine, sorry. You will be writing it as bis ethylene 1,2 diamine, dichloro, cobalt 3. So you got to understand what are the ligands present in alphabetical order. If you write it, this will come first, this will come second. So everyone will make this type of mistake. So what they will be thinking is, you will be writing dichloro, then you will be writing bis ethylene 1,2 diamine, right? You will be writing it as dichloro bis ethylene 1,2 diamine, cobalt 3. Which is correct? This is correct, this is wrong. Understood? Please be careful whether you are writing in alphabetical order or not. This is E. E comes after C. IUPAC name of the complex CONH3. So you have what you have? You have, this is cationic again, chloro, amine, nitrito, N. So in alphabetical order, if you see, this is amine comes first. So it is tetra, amine, chloro, nitrito, N cobalt. So it is 3. So this you erase the ligand part. Okay. So please make a note of this. Done? Next. So name the following coordination compounds according to the IUPAC system. So you want to name it according to the IUPAC system. You identify what is there here. Amine part is there. You write the ligand names first. Amine is there. Next aqua. Next chloro. So this is nothing but chloro, because this is your anionic part. So you have chloro. Again here, you can write chloro or chlorido also. That is not an issue. Chloro or chlorido, both are same here. Next for this, chloro. Remaining part you need to write it on your own, because this is very easy to write, right? Chloro. What are the ligands present? Then you can write it as, how many are there? This is dichloro. This is bis ethylene 1,2-diamine. Because there is diamine here, you will be writing as bis outside. Then you have chloride outside, chromium charge you will be writing it as. Or you can write En as ethane 1,2-diamine. Oh, I am writing it as mistake. So this is ethane. Ethane 1,2-diamine. Okay? Ethane 1,2-diamine. Write the IUPAC name of the complex. CrNH34 chlorine. Then you have positive charge. What is the type of isomerism does it exhibit? So you have chromium. So you write chromium at the last. This is cationic part. You write chromium. What is the charge you have? Oxidation state is 3. Next you have tetraamine dichloro. So you have a compound like this, MbA4B2. This is how your compound is. This type of compound exhibit geometrical isomerism. Geometrical isomerism. So you will be seeing it as. Okay. Please have a note of this. We'll be discussing about this isomerisms next. Done? So this will exhibit geometrical isomerism. Next. You have two structures. Write down the IUPAC name of the following. Write the IUPAC name of the, write the formula of this. So IUPAC name will be seeing here. So you have ethylene diamine. You can write ethylene diamine or ethane 1,2-diamine also you can write it. So here you write chromium is in again. So it is chromium. What is the charge present? X minus 2 plus 1. So it is 3. You will be writing chloride here. You have chloride here. Then what is the name here? You have diamine. dichloro. Next is what? You have only one here, dichloro. Then you have ene, right? Ene is what again? Ethylene, diamine. Then you have chromium 3 chloride. Then what is pentaamine nitrito O cobalt? This. So you have cobalt. Then you have amine, which is NH3 5 times. Then you have ONO nitrito. So you have minus charge here. So this is +2. So this is how you will get the compound name. So this is how you write the names of the compound. So these are very important. The exams which they used to put as subject to exam previously, the questions were very, very good and very interesting. So please make a note of all this. So done. You can write this in the brackets. Next. Write down the IUPAC name of the following compound. So you have pentaamine. Next is chloro, cobalt. What is the overall? +1 and 3. So it is cobalt 3. This is your structure. Next, write down the formula for the following complex. Potassium tetrachlorido nickelate. So what is there? Potassium is there outside. Tetrachlorido nickel, you have Cl4. Generally nickel 2 oxidation state. So you have +2 here. So overall you will be having a -2 here with oxidation state as +2. So you need 2 potassiums. So overall then it will have +2 here. So you won't be writing charges on the top generally. So it is like this. So it is potassium, nickel, Cl4. This is how it will be looking like. Next. Using the IUPAC norms, write the formula for the following. Sodium cyanidoorate. So you have orate, which is Au. You have Au, then you have dicyanide twice. So this charge will be a negative charge. So you require only one positive charge, which is one sodium, to balance this. Because see, this is +1 charge. Oxidation state is given as +1. So -2, 1 -2, overall charge will be minus on this. So you need only one sodium for this. Tetraamine chlorido nitrito N, platinum. So you have platinum. Next, tetraamine. So it is NH3 4. Tetraamine. Chlorido, Cl is there. Nitrito, O. You have N-nitrito. So you will be writing it as NO2. Then these are kept in outside. You can keep this in brackets because N is the one which is directly attached to here. So you have SO4. So SO4 is -2. So -2 means you have a charge which is +2 here. So +2 overall you will be getting -2. So you will be having Cl. Oh, chlorido is there. It is not 2Cl. So it is Cl and nitrito. So Cl minus charge. So it is +2 and +2. So it is overall +4. So these are your IUPAC names. How do you write these IUPAC names? We have seen how many type of compounds did we see? We have seen a very n number of compounds. Cationic part, anionic part. Just remember the rules. You need to understand when you have many polydentate Polydentate ligands, you'll be like more than one donating groups as ligands. You need to understand if similar type of atoms are repeating, then in the compound name itself, if there is di and tri, you will be putting them as tris or bis. Then always cationic part will be put at the first. So if you have cationic part, names won't be changing. You will be writing metal names as it is, or if it is neutral also, you will be writing as it is with their oxidation state at last. So these are all important parts of your coordination compounds where they can be asking n number of questions. Now in the next class, we'll be discussing few important formulas, how the geometrical structure will be, what different kinds of structures you can see, and how different types of questions are there. There are still some theories which tells you the stability of the compound, why does it exist in that way. These things will be seen. So thank you. Please like, share and follow our channel. So hope you find this video very useful. Thank you for this.